Hi, I'm John Byrne with Poets and Quants. Welcome to our Faculty Spotlight series at the Anderson School of Management at UCLA, of course. Today we have a fascinating professor to present to you, Daniel Benjamin, who actually has a joint appointment with the Department of Human Genetics at UCLA's Geffen School of Medicine and the Anderson School. Welcome.
Thank you, great to be here.
So you have an unusual background. You have a PhD in economics from Harvard, master's in mathematical economics from the London School of Economics, a master's in statistics from Harvard, as well as an undergraduate degree in economics from Harvard. And yet you are at the center of a relatively new multidisciplinary field that marries the science of genetic code with economics. How did that happen?
It's a remarkable place that I've ended up. I would never have guessed that I would be here and be affiliated with the medical school, as well as the business. I mean, the business school makes sense, but the medical school wouldn't have guessed it. I was fortunate when I was in graduate school to work with some of the founders of behavioral economics, which was around 2000. It was becoming clear that the social sciences and the natural sciences were going to become closer together over time, that there were going to be these multidisciplinary fields. At that time, the one that was clearly emerging was neuroeconomics, which is the study of decision-making in the brain, and that was beginning to influence economics and psychology. Also at that time, the Human Genome Project was getting completed, and one of my advisors from Harvard, David Leibson, had the foresight to see that that would matter too for the social sciences someday. And so with him and others, we started on this journey of trying to link genetic variation with behavior. And here I am 20 some years later, still doing it.
Right. Now you're also interested in the meaning of well-being. And I wonder how that interest manifests itself into your research and your thinking.
One line of my research is on measuring well-being, which is something that governments have become increasingly interested in recent years. And what I've done with a number of colleagues is to try to develop better ways of doing that kind of national well-being tracking through surveys, so asking people about things that matter in their lives, and then aggregating that information into an overall measure of well-being that could be tracked and used for policy purposes, much the way we use gross domestic product, GDP. The methodology of creating a measure of well-being is more broadly applicable, and indeed I've done consulting work that builds on the idea of creating an index to measure something that's hard to measure.
Are there other things in your future that you're burning to study and discover?
On the topic of the well-being work, I would like to extend apply our methodology to create a real well-being index for the United States, which we're working on now. We're going to work with a nationally representative sample and track it over time. It's going to be the UCLA Anderson National Well-Being Index, and we'll demonstrate its usefulness for evaluating policies and looking at differences in different segments of the population. I'm excited about the ongoing genetics work. I think we're learning more and more about the genetic influences on a variety of traits. And I'm looking forward to bringing the insights from my research to the real world organizations that I work with. And some of that hopefully will be through students who I work with who want to take away some of the things that we've learned together and into their own careers.
Now you have this joint appointment, and it means that you're teaching both the med school and the business school. And you have this really unusual course at Anderson called Precision Healthcare. And what impresses me most about this course is how you developed it with the students. Explain how that happened.
When I joined Anderson, it was clear that a priority for the school was building our healthcare program. We have a lot of MBA students who go into the healthcare sector disproportionately more than at other top business schools. And I spoke to the students to try to figure out what course would be the course that would be most useful to them, as well as faculty who were involved in the healthcare program, and realized that precision healthcare was an area that was both of great importance to the future of the healthcare industry, important, therefore, to the careers of the students, and it was an unmet need in the curriculum.
Now, what is precision healthcare? Because I think of healthcare as pretty unprecise.
Like precision medicine, which may be a more familiar term, it's also been called personalized medicine. It's gone through a few iterations of branding. But the idea is to target particular interventions to the characteristics of the person. So that could be their genetic profile. For example, when you're treating cancers, you take a genetic sample of the cancer cell, and that is crucial in determining what's going to be the most effective treatment for many kinds of cancer. And the reason why the course is precision healthcare rather than precision medicine is that this idea of targeting the intervention is broader than just the medical system per se.
Now, what you teach in this course, does it come directly from some of the research that you've done?
So I bring in my some of what I've learned from genetics and some of what I've learned from behavioral economics, where it's relevant, which is in much of the course. The course is really designed around the core business issues that come up when you're creating an organization that is trying to do precision healthcare. In the precision medicine context, if you're going to try to target treatments based on genetic information, you need to have enough genetic counselors who can help interpret that information. And that's a major bottleneck right now. So a lot of medical treatments could be a lot better if we, as a matter of course, collect the genetic information on patients, which is pretty cheap these days. That's not the problem. But what you do with that information, how you make it actionable, that's currently a bottleneck.
That sounds like a good job for ChatGPT.
AI in healthcare is one of the things we talk about. You're absolutely right. It's could be part of what will make precision healthcare work. One of the lessons in the course is that there's actually a long history of trying to use AI in healthcare, and it was a massive failure. They poured tons of money into it over a number of years and ended up giving up. The right kind of AI that's going to be most helpful in healthcare is going to be pretty specific in terms of its capabilities.
Yeah, that makes sense. What ultimately do you want your students to take away from the course?
Course is really designed around students getting out of it whatever is going to be most helpful to them in their careers.
Now, this is a burgeoning field. You've been involved in co-founding a consortium of scholars in this field. Tell us a little bit about that. What are you hoping to achieve by bringing scholars from all over the world together in this sort of unique multidisciplinary effort?
So the goal of the work that we're doing in social science genomics, or genoeconomics, we sometimes call it, is to link genetic variation to variation in behavior. And behavior is very broad. It means all sorts of different kinds of behaviors. A person's propensity to take risks, how much education they end up getting in their lives, their personality traits. All of these are things that we are interested in understanding the genetic links to. There's also many business applications of the research. Some of those are in healthcare, predicting related to precision healthcare, predicting which kinds of interventions are going to matter and work better for some people than others. There's also a growing industry of direct-to-consumer genetic testing that is building on what we're learning about the links between genes and behavior.
I imagine that what you discover many times is that the limitations are as plentiful as the opportunities. So the ability to control something because you know more about it than we had previously may sometimes be frustrating because you may also know that you're constrained to do much about it. This goes back a little bit to the marshmallow test and your subsequent study to find out how predictive it was of self-regulating behavior, right?
Yeah, for those who haven't heard about it, there's this famous experiment where 4-year-olds had a marshmallow put in front of them, and they were told that if they could wait long enough, then they could have not just that one marshmallow, but 2 marshmallows. And so the experimenter would put the marshmallow down, tell the 4-year-old what the instructions were, and then leave the room. And then, unbeknownst to the child, there was a camera recording what the child did.
And whether they were interested in instant gratification or had the patience to wait, knowing that the reward would be greater.
Exactly. So the early research was about different strategies that children adopted that helped them delay gratification or not. So for example, kids who could imagine that the marshmallow was a cloud, they did better than the kids who tried to smell the marshmallow, which tempted them more to eat it. And then later research looked at whether variation across the kids and how well they could delay gratification predicted their later life outcomes, like their SAT scores, for example. So what I did with a number of colleagues, including some of the originators of the Marshmallow Experiment, like Walter Mischel and Yuichi Shota.
At Stanford.
Exactly. We looked at the predictive power for a wide variety of outcomes for these kids who are now in their 50s, middle-aged. What we found was that, in fact, the predictive power is actually extremely low, very close to zero for a range of outcomes later in life.
Now, Dan, if I were able to access and examine your DNA, would I find the source of your intellectual curiosity that has led to your study of these things?
If you could, that would be I would love to write that paper with you. It's a serious issue in this area that although we're increasingly successful at predicting behavioral traits with DNA, it's often very hard to pin down exactly why particular genes are related to the outcome. Yeah. And the problem is that for things like intellectual curiosity, there's no gene for that. It's like what the gene is doing is something very, very close to biology, like affecting, neuron development. And then through some very complicated process over the course of a person's life that ends up in some cases, under some circumstances, influencing intellectual curiosity a tiny little bit. But in aggregate, when you add up all of these genes that we're identifying, they have reasonable predictive power.
Daniel, it's been a pleasure.
Thank you, John.
All right, this is John Byrne with Poets and Quants. You've been watching our faculty spotlight on the Anderson School of Management professors, and in particular, obviously, Daniel Benjamin, who has a joint appointment at the Geffen School of Medicine and the Anderson School. Thanks for watching.